Okay, this is the second video from 3.6, 2.6 in the 6th edition, and it's about the composition of functions. So this is the other way that we can combine functions. Previously we did the adding, subtracting, multiplying, dividing, and now we're going to do what we call composition of functions. So the notation that we use for composition of functions is a small little circle. So we would write f composed with it, which is this little circle. It's not an O, it's kind of a midway up, and then f composed with g. What it means is f of g of x. So if when you see the composition symbol you just change it to f of g, then you know how to plug that in, right? In other words, we're finding g of x. We find g of x first, and it could be a number in there. We would then plug the number in, whatever, and then we plug that into our f of x. Okay, so in this case, we would take g of x and plug it into f of x. So it would be our 2, because I'm working with the f of x function right here. So 2 times, and instead of x, I'm going to put g of x plus 3, right? And then I would simplify, and I would get 2x squared plus 4 plus 3, which means this would be plus 7. Okay? So that's composition, and you notice if I did g composed with f, it would not turn out the same, right? I would have f now being plugged in because it looks like this. So now I'm going to take f, plug it into g, so 2x plus 3 all squared plus 2. Okay, so doesn't turn out the same. I actually have to square this out. You know, 2x plus 3 times 2x plus 3, so I get 4x squared. And then I get 6x plus another 6x, so that would be 12x plus 9 plus 2. So I end up with 4x squared plus 12x plus 11. Okay, so that's how we do the composition. Now all of these functions have all real numbers as the domain, so it's not going to matter what we plug into it. So the domain would just be all real numbers. But let's look at one where it's not all real numbers. Okay, so let's do f composed with g. So you see that the domains of these are not all real numbers. So before we write that, let's find the domain. So the domain of the first one would be we would want x minus 3 to be greater than or equal to 0, so x is greater than or equal to 0. Or in other words, greater than or equal to 3, sorry. So we would write that from 3 to infinity. And the domain of this one would be that x is not 0. Okay, so when we write f composed with g, which means f of g of x, so the first thing I'm plugging into is g. I don't plug directly into f. It goes through g first. So even though f has this domain of 3 to infinity, may not have anything to do with our final thing. What I do know is x can't be 0, because if x is 0 when I plug it into g, it already doesn't exist. Okay? So I know for sure in my domain that x will not be 0. And now you notice that what I'm going to do is I'm going to plug in 1 over x into that square root, right? So now this is what has to be greater than 0. It doesn't even matter what I plug in for x. So even though this domain is 3 to infinity, you know, when I plug into x, I'm looking at 1 over x. Okay? So, like if I put 1/4 in for x, 1 over 1/4 would be 4, minus 3 would be 1. So 1/4 works, even though it's not in this domain. Okay? So what I really want to do is look here where I said x has to be greater than or equal to 3. Well, really what that means is 1 over x has to be greater than or equal to 3. So when I'm finding the domain of a composition, I do include the domain from the inside. That's for sure. But after that, I plug in that g of x into the domain of the f. It has to work. Not x, but g of x has to work. So how would I solve this equation? Well, we did exactly these kind of problems in 1.6. We take 1 over x minus 3 is greater than or equal to 0, right? And I'll change this to have a common denominator. So I have 1 minus 3x over x greater than or equal to 0. I'll look at a number line, and the bottom would be at 0. And we would not include that because we never include the bottom. And the top, if I set that equal to 0, it would be 1/3. So, and I am going to include that because it's okay for the top to equal 0. Now, let's look at these intervals. If I have it less than 0, like -1, I would get 1 minus a negative. So 1 plus 3, that would be 4, over a negative, so that would be a positive over a negative, so that would be a negative. It's kind of hard for me to tell this middle one, but if I choose just a small number like 1/6, that's a positive number on the bottom, right? And on the top, 1/6 times 3, that's going to turn out less than 1, and so it would be 1 minus some number less than 1, so that would be a positive number. I'd have positive over positive. And then, of course, bigger than 1/3, say like at 1, I would get a negative on top, positive on the bottom. So the only place that this works is from 0 to 1/3 inclusive, right? So that is my domain. That is my domain of this composite function. All right, here's a couple of functions. So let's find the composition of an f composed with g. I could do g composed with f, but it really wouldn't matter as far as what we're going to do. Okay, so I'm going to take g and plug it into f, right? So basically I would have 3 plus 1 over, and then I want g in here, 4 minus 1 over x. So now let's look at the domain. Okay, so first of all, the g has to exist. So the domain of g is that x cannot be 0. So we'll make sure we know x is not 0. Now, in addition to that, when I plug G in, it has to fit in the domain of F. So the domain of F is that X can't be 0. So I'm going to look at where G is equal to 0, and I'm not going to let it be that, right? So I'm finding out what it can't be. So that would be the same as 4 equals 1 over x. And I can multiply both sides by x and divide by 4. Okay, so x cannot equal 1/4. Now, why could I multiply both sides by x this time and last time I couldn't? Well, because I had an inequality last time. So I had a greater than. And remember that I can't multiply by a variable when it's a greater than. But I can when it's an equal to. It doesn't matter if x is positive or negative. It doesn't change anything. So in this case, these are my two numbers that don't work in the domain. Okay, so I would write my domain in interval notation as negative infinity up to 0. I want to make sure I get these in order. 0 to 1/4. And then 1/4 to infinity. Okay? So that would be the domain of this function, f composed with g. Okay, so here's the quiz question. Here's two functions. F is 1 over x and g of x is 2x plus 1. Find the domain of f composed with g and write your answer in interval notation. So once again on the quiz, I don't want the function. Just write the domain in interval notation. Use INF for infinity.